In this video, we're going to look at the equation of the line and what it tells us. So before we get into that, we're going to do a little investigation and look at some definitions. So we already know that the slope is the steepness of a line. The x-intercept is the point a line hits the x-axis, and likewise the y-intercept is the point where the line hits the y-axis. So we're going to just look at these four lines and write down the slope and the y-intercept. So the first line is y equals x, which is the purple line. Now if I'm trying to calculate my slope here, I'm just going to pick 2 points that I can clearly read off. So maybe here's a nice point, here's a nice point. I'm rising 1 and I'm running 1, which means my slope is 1 over 1 or 1. The y-intercept is right at the origin, so it's 0. Let's try the next one. Y equals negative 4x plus 5. This is the green line. When I look at it, here's a nice key point, which is actually the y-intercept, which is 5, so I'll write that in. Another nice point is right here at 1, 1. So I'm going 1, 2, 3, 4 down and 1 to the right. So negative 4 over 1, which is negative 4. The next one we have negative 1/2 x minus 3. Here's my y-intercept of negative 3. And then if I try to find another nice clean point, maybe this one. And again, the line's going down, so I go down 1, and then my run is 2. So negative 1/2. And finally, 2x minus 7. Here's the y-intercept at negative 7. And I'll use that as a clean point. And then here's another one. So I go 1, 2 up, and 1 to the right. So my slope is 2 over 1, or just 2. Now, if you look at the equation of the line, first of all, they're all starting with y equals. Now, two other observations. First of all, maybe the easiest one, the y-intercept is always the constant at the end of our line. And you'll notice for the first one, we had nothing at the end, which is technically plus 0. So that constant is the y-intercept. So if you look at this generic equation of a line, which is y equals mx plus b, b, the one not attached to x, is always going to be your y-intercept. So just by looking at the equation, you can tell me where the line hits the y-axis without looking at a graph. Now let's look at the slope. The first slope was 1, which is what the coefficient of x is. The next slope is negative 4. That's the coefficient of x. Next one is 1/2. Here's the 1/2. And positive 2, here it is. So the number in front of the x, including the sign, is our slope. So two very important features taken straight from this equation. And again, it has to start with y equals. So let's take this and fill in this table with this new information that we just learned. So our first line, y equals negative 6x plus 10. The slope is the number in front of the x, which is negative 6. Now, because I see I need to write down my rise and my run, I know slope is rise over run. So if my slope isn't a fraction, I can just put it over 1. Now I see the top number is the rise, the bottom number is the run. And then for my y-intercept, this one is just the constant that is left over, so the 10. Let's try again. Y equals 2 over 3x minus 7. In front of the x, I see 2 over 3. This tells me the rise is 2, the run is 3, and then the y-intercept is the constant at the end, which is not 7, but negative 7. The sign goes with it. All right, the next one, y equals x over 1. Now remember, if you don't see something in front of x, it is automatically just a 1. So why don't you try to fill in this row and then come back to check your work. So your slope is 1, which we can write as 1 over 1. Rise is 1, run is 1. And your y-intercept is the constant at the end, which is the positive 1. Now finally, y equals negative 3 over 4x. There's no constant at the end, but I can always write plus 0 because adding plus 0 is not doing anything. Now my slope is negative 3 over 4. Take that negative and put it wherever you want, either on top or bottom. Normally people will put it on top. So that way we know where to put the negative for the rise or the run. So my rise is negative 3, my run is positive 4, not both. Don't put the negative in both the rise and the run, or else we know that two negatives make a positive, so then that wouldn't match our equation anymore. And then the y-intercept, because nothing was there, I just put that plus 0, which means the y-intercept is 0. Now here I gave you the equation and we had to pull away the key features. But we can also go in the other direction. I'm going to give you the key features and we have to write out the equation of the line. The equation of the line will always be y equals mx plus b. So the slope is negative 5, so that would be our m, and the y-intercept is 3, so that would be our b. So we literally just replace these two values in our formula. Y equals, instead of m, negative 5x. The x has to be there, that's what makes it the slope. And then the y-intercept is positive 3, so plus 3. Make sure you put a sign there. The next one, my slope is 2, so there's m, and the y-intercept is 0, 8. So here I just gave you the y-intercept as a coordinate. The 8 is the y-intercept. So let's put it together. Y equals slope x, so 2x. The 8 is positive, so plus 8. Why don't you try this last one on your own? So pause the video and then come back. All right, so our slope is negative 1/2. The y-intercept is the negative 5. When we put it together, y equals negative 1/2 x. Subtract 5 because the y-intercept was negative. If you wrote plus negative 5, you don't want to keep the double sign. The negative will take over. All right, so here I just outright gave you the slope and the y-intercept, but we know how to read these things off of a graph. So let's try to find the equation of a line from a graph, which just means find the slope with rise over run, find the y-intercept just by looking at the graph, and then put it together. So let's start with the y-intercept. I always think that's the easiest. The y-intercept is right here, which is at 1. And then for the slope, identify two key points, which I already have for us. So from this point, I can draw my triangle. The line is going upwards, so I know my slope will be positive. And now we just count. 1, 2, 3, 4, 5 for the rise. 1, 2, 3, 4, 5 for the run. Now, like always, reduce that fraction. 5 over 5 is actually just 1. So now, when we put it together, y equals slope x plus the y-intercept. Now, you can write it like this, but this would be the better communicated form. If the coefficient's just 1, you don't have to write it. But you can if you want to. All right, the next one. The y-intercept is already nicely labeled for us. It is 2. And now let's draw our little triangle from the 2 points. So I have a rise of 1 and a run of 4. The line is going upwards, so our slope is 1 over 4. Put it together, y equals 1 over 4x plus 2. Don't forget about the x. Now I want you to pause the video and try this last graph on your own. I will just make a note that this line is going downwards, so your slope will be negative. So pause here, try it, and then come back. All right, so here's our y-intercept of 5. And now for our triangle, we're going down 4 and then 2 for the run. So negative 4 over 2 would be your slope. Make sure rise goes on top. And this will actually reduce to just a nice negative 2, so that our equation is negative 2x plus 5. If you forgot the negative, if you flipped your fraction the wrong way, make a note of it so you don't do that in the future. All right, and finally, we also know how to find the slope from a table of values. So that's the final type we will do. So from a table of values, we can find the slope by just picking two sets of values and subtracting the x's and the y's to get our slope. So I'm just going to pick this one here because they're all positive numbers. And remember, we do bottom minus top. So 11 minus 9 is 2. 1 minus 0 is 1. Also remember, y is rise, x is run. Think about that other slope formula, y2 minus y1 over x2 minus x1. The y's are the rise because the y is vertical. All right, so that means our slope is 2 over 1, which I would just write as 2. Now for your y-intercept, I'm just going to draw a little grid right here. The y-intercept is always on the y-axis. So any of these points could be a y-intercept. Any of those coordinates have an x value of 0, 0, 1, 0, 5, 0, negative 3. So a y-intercept, we're always looking for the row in our table where x equals 0. And here it is. And what is the y-coordinate? 9. So that means our y-intercept is 9. So y equals 2x plus 9. Let's try the next one. And again, let's find the y-intercept first. Where is x equal to 0? Right here. And the y-coordinate is 2. Now for the slope, pick 2 points. I'll pick these middle two. 5 minus 2 is 3, and that's our rise. For our run, 2 subtract 0 is 2. Make sure you are looking at both the x's and the y's. So putting it together, y over x, 3 over 2. So our equation, 3 over 2x plus 2. Here, I want you to pause the video for this last example, identify that y-intercept, find your slope, and put it together. Then come back to check your work. Okay, here is our row for the y-intercept because that's where x is equal to 0, and the y-intercept is 6. For our slope, I'm going to pick my first 2 coordinates, but you could have picked anything. So for my y, bottom minus top, 1 minus 6 is negative 5. And for my x's, 3 minus 0 is 3. Again, maybe make a note, bottom minus top. Our rise is the y, so negative 5, and our run is the x, which is 3. Putting it all together, negative 5 over 3x plus 6 will be your equation. And that's it for the table of values. So let's just fill in this final summary box, and then that's it. So for the slope, for a graph, you are just counting your rise and run. So I'm going to make a note that we use our rate triangle, and then we do rise over run. Very visual from the graph. From the table of values, our rise is to subtract the y's. Our run is to subtract the x's. And again, that little note, the bottom value minus the top value. So that's your slope. For the y-intercept from the graph, look at point on y-axis. For the table of values, look at y when x equals 0, always when x equals 0. And then once you have that all together, plug it into y equals mx plus b, and that's it. So again, the equation of the line is y equals mx plus b, M is your slope, B is your y-intercept. The slope is always attached to the x, and the y-intercept is always that constant.